Hi, this is Nathan Tintle. In this learning goal video, we will talk about how large values of the MAD statistic are stronger evidence against the null hypothesis. We will use the coming to a stop dataset to talk about this learning goal. To compute the MAD statistic on this dataset, we find the differences between all of the different groups. We then make those numbers positive, so 12.9%, 4.7% becomes positive, 8.2% make it positive, and then average those numbers together to get the MAD statistic, 8.6%. What does this number mean? Well, 8.6 is the average difference these groups are from each other. So are big numbers more evidence against the null hypothesis or less? Let's look at a quick example. If the groups are more different from each other, how does that impact the MAD statistic? Well, let's take the existing data and change it. Let's make the lead car stop 95% of the time. This gives us differences of 17.4% and negative 9.2%. We make that positive, we average them together, we get a MAD statistic of 11.6%. And before, we were at 8.6%. So if we make the groups more different, then their mean absolute deviation, their MAD statistic, is larger. A couple of words of caution. Because we are averaging the numbers together, make sure to use positive differences to avoid cancellation. Remember that bigger differences always result in bigger values of the MAD statistic. Finally, very small values are not evidence against the null. Think about what a MAD statistic of 0 means. This means that there's no differences in the groups. That would be sort of as little evidence as you could have against the null hypothesis. Can you have negative values in the MAD statistic? No, you can't. You're averaging positive numbers together. So the MAD statistic will always be positive, and values close to 0 are very little evidence, and values much larger than 0 are stronger evidence against the null hypothesis.